Hello everyone, welcome back to Kapil Joshi tutorials. If you are learning machine learning or preparing for university exams, so today's video is going to clear one of the most confusing topics in support vector machines, that is the decision vector. Many students search for the meaning of the decision vector, but here, an interesting fact that decision vector is not actually a standard technical term in SVM. Instead, the decision-making process in an SVM is mainly determined by two important components. Number one, weight vector, that is W, and number two is bias term, B. Let's understand these concepts within an example, simple example we are taking. Number one, like we are discussing, what is a decision vector? In support vector machines, the goal is to separate different classes of data using the best possible boundary that is called hyperplane. Some study materials use the term decision vector, but in standard machine learning literature, the decision boundary is mathematically defined using the weight vector, represented by W, and the bias term represented by small b. So together, these two components determine where the hyperplane is located and how it separates the data into different classes. The decision function of an SVM is fx is equal to w product. It means w dot x plus b. This is the sign of multiplication. So here w is the weight vector, x is the input feature vector, and b is the bias term. The sign of the result tells us which class the data belongs to. The weight vector w. Now let's understand the most important component, the weight vector. The weight vector controls the orientation or direction of the hyperplane. Think of the hyperplane as a straight line dividing two groups of students, so those who passed an exam and those who failed. So if we rotate this dividing lines, different student may fail or sometimes can be fall into the different category. The rotation is controlled by the weight vector. Mathematically, the weight vector is always perpendicular or at a 90-degree angle to the hyperplane. It also determines how important each feature is in making the classification. Suppose real-time example we are taking. Imagine a bank wants to approve or reject loan application. The machine learning model considered several features like income, credit score, existing loan, or age. So each feature has a different importance. For example, credit score may have a weight of 0.8. So income may have a weight of 0.6 and age may have a weight of 0.2. The higher the weight and the greater the influence of that feature on the final decision. So the weight vector tells the SVM which features matter the most. The second term is bias term. Next comes the bias term, also called as a intercept. While the weight vector determines the direction of the hyperplane, the bias term determines its position. Imagine drawing a straight line on a whiteboard. Without changing its angle, you slide the line left or right. That's exactly what the bias term does. It shifts the hyperplane closer to one class or the another without changing its orientation. Again, we are taking an example of bias term. Suppose a university select student based on entrance exam marks. So initially the cutoff is 60%. Later the university decide to increase the cutoff to 70%. We are increasing the marks from 60 to 70. The direction of the decision boundary remains the same, but its position change. This shift is represented by the bias term. So, why both are important? The weight vector and the bias term work together to create the best decision boundary. The weight vector answer in which direction should the boundary face, and the bias term answers where exactly should the boundary be placed. So without the weight vector, the classifier cannot determine the correct orientation, and without the bias term, the hyperplane cannot be positioned correctly. So together, they maximize the margin between different classes, making the classifier more accurate and reliable. So let's quickly revise decision vector. It's not a standard SVM term. So decision vector is defined by the weight vector W and bias term B. And weight vector determines orientation, feature importance, and direction of the hyperplane. On the other side, bias term determines position, intercept, and shifting of the hyperplane. And together, they define the SVM decision function. Fx is equal to W dot x is equal to B. Now, if you found this explanation helpful, do not forget to like, share, and subscribe to Kapil Joshi tutorial for more easy to understand videos on machine learning, artificial intelligence, data science, and many more. Thanks for watching, and I'll see you in the next video. Bye bye.